Good morning, grade 8s. Welcome to lesson number 2. So we finished on page 75 yesterday, and so now we're on page 76. And we are discussing what an atom looks like and what it has in it. So the center of an atom. So now we're looking at something like this. See? Or simpler, like those circles there. So that's center. There's a big dot in the center. It's big and it has all the mass in it, and it is called the nucleus. The nucleus contains protons and neutrons. So protons are positive. They both have a P. Neutrons are neutral. They both have an N. It's nice to remember. Then that whole big cloud around that big mass, it still has little particles, so little balls, in that sphere. It's like a cloudy mess. Those are called electrons. Now, electrons are negative. Atoms are neutral because of the number of negatively charged particles is equal to the number of positively charged electrons. Protons and electrons, they always have the same amount in an element. So if you have 6 elements, if you have 6 protons, you have 6 electrons in your element. If you have 50 protons, you have 50 electrons in your element. Okay. Making models of atoms. I'm sure you guys have either seen this done at the school or you've done it yourself in grade 7. Models are used to show a real life version of something, but obviously atoms are so small we can't even see them with our naked eye. So it's a lot bigger. It's a magnified version of it, but it's so that we can look at it, touch and see how it actually works. So how to determine the number of subatomic particles in an atom? So I've drawn a little block for you in your notes, and it's for sodium. So there's the atomic number at the top and the mass number at the bottom. The mass number has all your protons and neutrons. Remember, that big mass in the middle has your protons and neutrons, so it's your mass number. Then your atomic number has your number of protons. Now remember, if it has your number of protons, it also has your number of electrons because they are the same. So for sodium, there are 11 protons, so therefore 11 electrons, and there are 24 protons and neutrons. So how are we going to find out how many neutrons there are? So if we have protons, and we have protons and neutrons, if we want the neutrons, we need to minus the protons away from those. So we're going to take our mass number minus the atomic number from it, and we'll get our neutrons. So 23 minus 11, you'll get 12 neutrons. So 12 neutrons, 11 protons, and 11 electrons. And that's your whole element. And every element looks the same on your periodic table with the same numbers all at the top. So you now know how to find all your particles in an element. Remember, protons, positive. Electrons, negative. Neutrons, neutral. Mass number, it's all that mass in the middle. It's heavy, okay? So on page 79, we have pure substances. If you think of a pure substance, it doesn't have any mess or mix. It is perfect. It is clean and everything is the same. So you get pure substances or mixtures, and we'll discuss mixtures in our other lessons. But for now, we're going to focus on pure substances. So elements and compounds are pure substances. So elements, in your periodic table, you can't break elements down. An element is an element. You can't do anything about it. So hydrogen, helium, lithium, beryllium, all of those. But then compounds are 2 elements put together. So like water is a compound with hydrogen and oxygen. Now they can be broken down, but it's still made up of elements that are pure. So it's still a pure substance. So elements and compounds are both pure substances. So for elements, it's because all of the atoms in a specific element are the same. And for compounds, it's because all the molecules of a specific compound are the same. So like you can see, we have a water example here. So even though we have a mixture of hydrogen and oxygen, H2O, yes, hydrogen and oxygen, the molecules are still all the same. There's one oxygen and two hydrogen. One oxygen, two hydrogen. They're all the same, regardless of the fact that there are two elements in this compound. Where if we can see our gold particles, they're all exactly the same. So, of course, they're pure. There's nothing different. There's nothing mixed in with them. They all are the same. A pure substance is the same all the way through. So that's easy to remember. Pure substance, same. If there's anything different, if there's no pattern, think of it as a pattern. So even with our table salt particles over here, there's a pattern. So remember, if there's no pattern or if everything isn't the same, it's not a pure substance. Because it's not pure. It's not doing and reaching the format for a pure substance. On page 80, we have pure substances have specific properties. So in your notes, I made little check boxes for you, a list to check. So you investigate a pure substance by asking these questions. You'll have a look at the list in your notes. I made little boxes as well. Phase. So what are phases? Phases are your solids, liquids, and gases. So you go and you tick your box. Is my element a solid, a liquid, or a gas? Then you go to conductivity. When you can conduct something, you conduct electricity. So your wires at home conduct electricity, but the plastic fork doesn't conduct electricity. So you have conductive or not. Solubility. Is the substance soluble or insoluble in water? So will it dissolve and mix with the water molecules, or won't it? Density. Does the substance float or sink in water? Magnetism. We all know magnets. Is the substance magnetic or not? And melting point. At what temperature does the substance melt or freeze? This obviously depends on melt if you're working with a solid and freeze if you're working with a gas or liquid. Then finally, boiling point. At what temperature does the substance boil or condense? It also depends in what phase your element is in. So we've given an example here. Sulfur's boiling point is 445 degrees, but water is 100, and that's an example they'll give you a lot. Water's boiling point is 100 degrees Celsius, and its melting point is 0 degrees Celsius, because it's already water. Sulfur, 455 degrees Celsius and 119 melting point. So remember, it'll be a question asked throughout high school if you choose to take biology as well. Water's boiling point is 100 degrees Celsius. Its melting point is 0 degrees Celsius. So I'm going to give you guys lesson activity 4 on page 77. And so you do the first 10 elements. So activity 4, copy the table below into your books. In the first column, write down the names of the first 20 elements. I want you to change that to the first 10 elements. Use the periodic table at the back of this book to complete the table. Then the diagrams below show models of certain elements. Write down the numbers of protons, electrons, and neutrons. Identify the elements. So we're working backwards. We're working out how many of those particles we have, and therefore which element it is. Remember to use your periodic table. And if you get confused, ask me whilst you're doing the homework. I'll be happy to help. Then also activity 6 on page 80, which is for each of the substances in the photographs below, decide whether the substance is a pure substance or mixture. So we're going to work out, remember, pure substance, is it all the same or is it mixed? If it's mixed, it's a mixture. If it's all the same and all made up of the same things and the same particles, it is a pure substance. So when you decide if it is a pure substance, you must decide whether it is an element or a compound. So I want you guys to try that one. If the element and compound confuses you, please ask me. You always know you can. So the next lesson, we'll start on page 81 with elements. So you must ask me if you have any questions. I hope you have an amazing day and work hard like I know you can. Thank you.